Hello and welcome back to our part 3 of describing common TCP/IP based attacks. Access attacks. Keep in mind as we go through these different explanations how a lot of these we have the word attacks, for example, the letter S at the end, indicating that there are plural, there are multiple of these styles of attacks. So when we say access attacks, trying to gain access to a system by compromising or guessing or discovering passwords, maybe spoofing or masquerading to pretending to be an already authenticated user, pretending to be a system that you are not, pretending to be a service that you are not. How about session hijacking? Again, we can do session hijacking at many different layers of the OSI model, whether it be, let's say, ICMP or TCP. And give us a moment, we're going to go a little bit deeper still, but taking over an already established and already authorized session and using it for non-authorized services. And then, of course, as we've discussed earlier, malware or mal software, bad software, software that I want to stress, malware being a very large category, and in my opinion, a growing category of malicious software trying to launch attacks against an infected or victim's system. Now, as we start going deeper and deeper, we're kind of revisiting what is referred to as the MITM or man-in-the-middle attack. Please understand, as there are multiple layers of the OSI model, multiple systems that make up a network, multiple protocols involved, we can also do our man-in-the-middle attacks at multiple different levels. Maybe it's a physical tap on someone's network where you are now in line and able to gather data and inject data at the physical layer. Maybe it's going to be, as we'll talk about in a moment, doing more of a redirection at layer 2 by MAC address spoofing or ARP poisoning, or moving our way on up to layer 3 of the OSI model, which is where we do a lot of addressing, IP addressing, and routing. So manipulating addressing and routing information to session layer. Session layer, one of the many things that session layer is responsible for, I always remember in my head, is session establishment, session authentication, session maintenance. So again, taking advantage of an already established session, maybe even trying to decrypt, manipulate, and re-encrypt the data between two systems. And then finishing up again with an application layer where you are masquerading yourself as the destination of interest so you can gather information. And I'm being very vague there, but it could be, again, a browser-based attack, a database attack, some kind of a service that the end user would normally use, but the attacker is presenting this for malicious reasons to maybe gather information. So again, going deeper into an example here, more of, as you saw a moment ago, a layer 2 ARP poisoning. The bottom line here is, in order to successfully pull off a man-in-the-middle attack, you need to have the victim think that while they are communicating with the attacker system, that what they're really wanting to do is communicate with a known destination. So again, we need to do a redirection of their traffic. And ARP poisoning is one of the great ways of doing that. So the basic idea here is that the unknowing victim is trying to communicate with a destination address. But what they do not know is, of course, we have to pass through layer 2 devices, whether it be switches, whether it be access points for wired or wireless. Well, those devices have at layer 1 and layer 2 MAC address tables, mapping egress port to a destination MAC address. At layer 2, layer 3, they have ARP tables, mapping a destination IP address to the MAC address. And then again, those two tables, going backwards now, ARP tables and MAC address tables, work together to build the full Ethernet packet, Ethernet portion of the packet, and to be able to forward, here's the key, forward this packet through the device, let's say switch, to the destination. So even though the slide right here is mentioning ARP poisoning, if we're able to poison ARP tables at layer 2, layer 3, if we're able to poison MAC tables containing layer 1, layer 2 information, both of those could be used to pull off a man-in-the-middle attack where, once again, the unknowing sources trying to talk to an intended destination actually end up having their traffic redirected or forwarded in a direction that was originally never intended. Now let's continue going a little bit deeper still into our man-in-the-middle attacks. We talked earlier about ICMP base, where we can do an ICMP redirect. Remember from earlier, ICMP has so many different options, or what's called an ICMP type. Many of them we don't even use, and even some of them can be used against us. Well, an ICMP redirect may be used in a valid scenario where we're trying to redirect a session maybe to the next router in a router cluster, or the next server in a server cluster. But they can also be used against us by forwarding redirecting packets in a direction where they were never intended. DNS-based man-in-the-middle attacks, where we try to get, let's say, for example, to acme.com, but the name to address resolution is actually falsified. So whereas we were trying to go to a valid IP address for the domain, the DNS value, we're being redirected because of a falsified entry. Let's say a DNS-A record, we're being redirected to a different IP address, more than likely an attacker's destination. And then again, DHCP-based man-in-the-middle attacks, in my opinion, starting from the very, very beginning, where end devices, let's say users, are trying to get IP addresses assigned and IP options assigned, but what they have no idea about is that the DHCP server servicing the IP address and IP option information is actually a compromised DNS server. So now instead of giving out valid corporate IP address, mask, DNS, router, default gateway information, the compromised DHCP server is actually giving out spoofed and invalid address and address information.